that technology is from the 1930s. So the old adage, right, of the fire service is we're slow to adopt, right? We 100 years of progress impeded by 100 years of tradition, right? So it's that way with suspension as well. So my goal is to really try to educate the customer base that there are alternate technologies out there. And I'm just trying to get them into the 1990s with Parabolic springs, right?
You're listening to another episode of Rig Recon Live. I'm Bruce Quick alongside Jason Witmier. And before we get started today, let's go over a couple housekeeping items. Make sure you're following us on social media. You can find us on Facebook and Instagram. That's at Rig Recon. You can catch this podcast wherever you get your podcasts, including YouTube. Make sure you subscribe and hit those post notification buttons so you know when every new episode drops. And then finally, visit our website, rigrecon.com, for all the latest apparatus information and where all this content lives. So great site to check out. This episode is presented by FRC. FRC, since 1968, has been manufacturing fire safety products and shipping them out to fire departments worldwide, which includes safety equipment, pressure governors, scene lighting, and so much more. If you want more information, you can visit fireresearch.com. So, Jason, today we're joined by Bob Obano. And Bob, I won't do much justice in introducing you, so I'll give you a chance to introduce yourself and give your background on the industry and more.
Yeah. I first appreciate you guys having me on. Let me come talk a little bit about my passion, which is suspension on fire apparatus. I started in the industry in 2006 with Rig Recon, which is a sister company now. Spent about 4 years there, focused specifically on fire apparatus. Took a couple year hiatus, stayed in the heavy duty trucking industry, but did some braking stuff. And then 2013, I got a tap on the shoulder from Hendrickson and asked if I'd be interested in coming back to suspension. So I've been with them. This is now my 13th year. Really in 2016, Hendrickson decided that they were going to go ahead and form these business units. And the goal there is for us to try to understand the marketplaces better. So my focus is specifically on fire apparatus. I handle our defense customers and then our agricultural customer base. And the intent there is for us to really understand the market and then for me to bring back information that says, hey, what do our products need to do in those specific markets to really meet the demanding needs of, say, the fire service? Because the way we drive a fire truck is very different than the way we design an on-highway truck. We're asking those apparatus to do very different things. So we wanted to really focus on that business segment. And that's where I've been focused really for 10 years now, making sure that the products that Hendrickson's putting in the market really meet the needs specifically for the fire apparatus that we're trying to service.
Awesome. So today we're going to talk about, we're going to call this basically under the chassis. So what's underneath that's keeping that fire truck on the road? A lot of people right away, they think, okay, it's a suspension. It's all about comfort. And, you know, you'll come almost knock people. Oh, he's a firefighter. He's in that truck for a few minutes running to a call. Why does he have to have the comfort and have this nice, smooth ride? It's so much more than that in an emergency vehicle. And that's what we're going to explore here today is why that suspension means more than just a comfortable ride.
Yeah. You have to look at it really twofold, right? What are we doing to the occupants, i.e. the firefighters, but then also what are we doing to the cab chassis and all the electronics, the frame rails of the truck? So obviously when we're trying to damper suspension or make it more comfortable, it's not necessarily only for the occupants. It's how often are we beating up these fire trucks? We're asking a lot of these fire trucks to be on front lines for 20 years. Well, every input that I put into that truck that's harsh, that creates more stress on the doors, the windows, the cabinetry, all of the things. So the goal of of suspension is not only to protect the occupants, but also to protect the apparatus and keep them on the road or in service more often.
And Bob, maybe we'll just start off with giving us an overview of the different suspensions available on the emergency market.
Yeah, so the way that we look at it is really twofold, right? You've got the front suspension and you've got the rear suspension, then you've got a system, right? So how do they interact between the two? So if we were to look at purely front suspension options today, there's really two different options that we look at in the marketplace. There's what we call a beam-based suspension. So that's going to be either a multi-leaf or a spring pack or a parabolic spring pack paired to a straight axle. And that can be a I-beam axle or that can be a fabricated axle like we provide in the marketplace. And then there are what we call independent front suspension. And there's really two ways to go about the independent action. And that is either through air ride or a mechanical solution. So there are two different options in the marketplace. And really, air versus mechanical is just a function of how you're trying to control how the suspension. So you either do it through a torsion bar where it actually winds up and provides resistance essentially to the suspension going up and down, or you use what's called an airbag. And as the airbag moves, right, the pressures control the suspension from traveling. So those are really your options for front suspension. When you get into the back suspension, it gets a little bit more, there's a couple more options there. We look at it for mechanical suspensions. There's really two different options there. And that would either be a mechanical spring, so metal leaf spring or a parabolic spring, or you can use what we call a rubber ride suspension. That's just another option that to provide weight. The third option is an air ride suspension, which is really becoming more accepted in the fire service. I think that originally what had happened, we as suspension manufacturers, we didn't have these business units, so we didn't really know where these suspensions were going. So we took kind of like a one size fits all approach. Well, air ride kind of got a bad stigma in that they didn't have a lot of roll stiffness in them. So as we're going in a fire truck around a corner at a high rate of speed, it had that sensation of rolling over on it itself. Well, as we as suspension manufacturers have gotten smarter and made sure that we're putting products in the environments that they're designed to be utilized in, we've done a much better job of giving the fire service an air ride that meets the needs of them from a driver standpoint, from a performance standpoint, but also from a vehicle equipment protection standpoint. Does a much better job than a rubber ride or mechanical suspension of protecting not only occupants, but also the equipment that's on the apparatus.
Nice. One of the things, so we already talked about the fact that this isn't just about ride quality. It's not just about comfort. So I know one of the things that we do get involved in is how the suspension can help us with handling and even stopping distance. Because if you think about it, one of the important things when it comes to stopping distance is keeping those tires in contact with the ground. And if I'm bouncing all over the place and my tires are coming up off the ground, then I can't stop. It's the friction between the tire and the road that really causes me to stop. Can you talk about how the suspension can play into that?
Yeah, so if you think of like a standard mechanical suspension, like a Reiko 79 KB, those have about 2 inches of wheel travel. So about an inch up and an inch down. So as you can imagine, as that suspension torques under braking, right, that wheel is trying to rotate forward and you get a lift off of the back of that suspension. So obviously the more wheel travel we can have, the better weight, the more opportunity we have to keep that wheeling in contact with the ground. So with an air ride, for example, with our Fire Max, that has about 8 inches of wheel travel. So about 4 inches up and 4 inches down. So obviously the more I can rotate that suspension, the better opportunity I have to keep that wheel in contact with the ground. And that's all a function of wheel travel. So wheel travel is there for two reasons. Obviously to keep the tire in contact with the ground, but also to provide ride quality. The more I can travel with suspension, the better ride quality I'm going to have.
And durability is critical in our market, right? And these apparatus are responding to harsh and sometimes extreme conditions. So maybe talk about if there's a suspension option that maybe lasts longer than the others or is good for a truck that's going to be in some extreme conditions.
Yeah, so durability is a tough one in that there's a couple things that factor into durability. And the main thing that we see that takes a suspension out of service is really corrosion. That's a big thing, especially in the Northeast or in the Midwest where I'm at, Chicago.
Rust belt.
Yeah. What happens is the mechanical suspensions, 90% of them use what we call a multi-leaf spring stack. So if you can imagine, you stack springs on each other, and as the pressure comes on them, they move and they slide against each other. Well, what tends to happen over time is that you get water in between the multi-leaf springs, and what happens is rust is created. So we call that rust jacking. So essentially what happens is as that spring tries to rotate against each other, you now have resistance built into the spring. So your ride quality goes down because you can't move the spring as easily anymore because you've got friction there that wasn't designed to be there. So that spring then will continue to rust until it fractures or breaks, and then we start the process all over again.
Sure.
My mission in the fire service by the time I retire is to eradicate multi-leaf springs from the fire service. We've got that technology is from the 1930s. So the old adage, right, of the fire service is we're slow to adopt, right? We've reached 100 years of progress impeded by 100 years of tradition, right? So it's that way with suspension as well. So my goal is to really try to educate the customer base as to there are alternate technologies out there. And I'm just trying to get them into the 1990s with parabolic springs, right? The benefit of a parabolic spring is they don't rub on each other. They're thick at the center point where we carry about 90% of the load is within about 10% fore or aft of the axle. That's where the majority of the load is carried. And then you have your axle or your springs go out to the ends where we thicken it up again. So the benefit there of a parabolic spring is it lets me thicken the spring in areas where I want to control the weight, and then I can thin it out. And the benefit there is I can now spray what's called a zinc-rich paint on those springs, and it doesn't rub it off because they don't essentially rub against each other. They just bend. And so that helps me from a corrosion standpoint to take out one of the big contributors of failures out of the equation. If I can protect the springs, I can keep the trucks in service a lot longer.
Sure.
On a lot of our podcasts, we talk about corrosion, and it's a problem everywhere. It's interesting to hear how it specifically is a problem here. Let's focus on the rear a little bit. So you already mentioned like a rubber block, a spring, or an air ride.
Yep.
Like everything, we talk a lot on these podcasts how there's give and take and everything. And everything on that fire truck, there's give and take. Sometimes if you're gaining a benefit somewhere, you're putting a detractor in somewhere else. What are some of the pros and cons of the two versus each other, of like a spring versus an air ride? And are there limitations on the weight for either one of them?
Yeah, I guess what's interesting to me is when I look at sort of the fire service market versus, say, the on-highway trucks, the only industry that I know of that will allow essentially mismatching of suspensions is the fire service, right? When you buy a Freightliner, for example, the front suspension is designed to work in conjunction with the rear. However, the fire truck will let you pair whatever you want with whatever you want, whether that's an OEM issue or me need to train people more or educate people more on why we want the system to work together. Today, if you put a multi-leaf rear suspension with, say, our steer tech on the front, you've got 7 inches of wheel travel on the front and 2 inches on the back. So what happens as that truck's going down the road is we can a big cantilever motion, right? So the truck's doing this the whole way down the highway versus if we would pair, say, a Hendrickson steer tech with a Firemax on the rear, those both have the same amount of wheel travel. They're designed to work together. So when the truck's going over bumps, it's doing this versus this, right? And so we're just trying to educate people on what the options are and how they play together, because whatever happens on the rear is translated to the front. And by the way, guess who's sitting right over the front of that axle? Oh, the firefighter, right? So they're feeling all of that. So it's more of a function of let's educate how the rear works with the front, and then let's try to make suspensions that work together. And I don't care if it's my suspension or competitors. They're all designed to play nicely together in the sandbox, and there's some configurations that don't play nice in the sandbox together, and then we get ride complaints, right? That's what happens. In terms of rear, you've got the mechanicals that we talked about, and then you've got air rides. There are some, I believe, when we talk to mechanics and I go out there, if we can get past the stigma of air ride and that it's going to leak or we're going to blow air springs, the airbag technology has come so far in the past 15 years that we don't see a lot of failures on airbags. And the benefit too, everyone talks about, oh my God, I failed an airbag, I'm not gonna be able to drive my truck back. Well, no, that's not true at all, because when an airbag fails, there's a bump stop in there. So it'll just sit down on the bump stop, and you're gonna notice you can still limp the truck back to the station and get it there. Same thing when you fail a multi-leaf spring pack, right? The spring breaks and the truck is sitting down, and then you got to go in and replace the spring stack. One of the things that people don't think about, if you're that mechanic, right? For example, when you have to go in and touch a clamp group, i.e. a multi-leaf spring pack, that spring pack weighs about 200 to 250 pounds, depending on the weight capacity, right? And then you've got U-bolts that you have to deal with, and that ends up being about a 4 to 6 hour job to replace a spring pack, because typically when you replace one spring, you're going to replace the other, because if it's failed, typically you want to put the same spring packs on, because spring packs can have different spring rates. They may be the same capacity in terms of a 24,000 pound spring, but different spring manufacturers have different spring rates. So you theoretically could put the same 24,000 pound spring on that could be 50% stiffer on one side than the other. So that's why you always want to match the spring packs together.
Sure.
When I talk to mechanics, right, we talk about the fact of what would you rather work on? An airbag weighs about 27 pounds on the biggest airbag weighs about 27 pounds, and it takes about 4 bolts for you to get in and out. I can change an air spring in 25 minutes versus 4 to 6 hours changing a spring pack, and it's a lot less labor intensive. So if I'm the mechanic and I'm having a choice, I know from doing it which one I would rather deal with. Plus, there are a lot of benefits to air ride. The challenges with spring ride is, we know on fire trucks, we don't load these things evenly from side to side, right? So what tends to happen? We've got a mismatch in weights from side to side. And what happens with the fire truck, right? We get a lean. And the only way to fix the lean is what? We stick a shim under there.
Spring in or something, yeah.
Correct. To stiffen the suspension, which is counterintuitive to what you want to do, because then you're actually just degrading your ride to hold the fire truck up. Air rides don't care if you've got 10,000 pounds on one side and 15 on another. They're going to automatically level load based on the loads that they're being asked to carry. And they automatically adjust. Another benefit is air rides don't care if the suspension is loaded or unloaded, or if spring rides are really susceptible to weight. You have to be within 90%. A rule of thumb that we use is you want that suspension to be within 90% at a minimum of the capacity. So at a 20,000 pound suspension, for example, we want to see a minimum of 18,000 pounds on that to be able to have enough pressure to move that suspension. Air ride is going to ride the same at the 20,000 pounds as it will 10,000 pounds, because it's going to automatically adjust the pressures that it's seeing in the airbag. So it's a really nice benefit and a protection against loading fire trucks and being spot on in terms of your weight calculations.
Question for you. You might not know the answer to this, and if you don't, it's fine. I've noticed you'll just make it up. I've noticed several ambulances out in the field where when they get on scene, they've got an air ride rear and they dump the air, which makes it easier for them to load the stretcher into the ambulance.
Yep.
I've never seen a fire truck dump the air on the rear, which would bring the hose bed lower to the ground. Any reason for that?
No, I mean, it's something you can do. There's no problem dumping the truck. If you wanted to get the hose bed down, that's 3.5 inches that you could get that truck down if you wanted it to. One of the challenges though is, so the air springs and the diameter of the air springs on an ambulance are a lot smaller than they would be on a fire truck. So it's really about recovery time, right? On an ambulance, we can recover that suspension a lot faster than we can, say, on a 31,000 pound suspension on the rear. So it's just, how long are you comfortable with sitting on site for you to recover that suspension to get it back to ride height so we can drive away safely?
Makes sense.
So nothing to say you can't do it. It's more of just a convenience factor.
Sure.
And Bob, you did talk about corrosion and started to go through, but maybe let's revisit and talk about, if there's anything preventative that you can do when it comes to corrosion and sort of how you approach the education to the market as well.
Yeah, the biggest thing that we're seeing, so standard spring manufacturers, and one of the things that we've tried to take more control of is we've got some technologies out there in terms of corrosion resistance, and it's mostly through paint. So a standard spring that you buy off the shelf from any of the spring manufacturers can utilize what we call water-based paint. And so the way we measure corrosion protection is salt spray hours. So when we look at a standard water-based paint, we'll put a spring in a booth and we'll literally spray water on it until we see what we call red rust on the surface. And the standard water-based paint has about a salt spray hour rating of about 50 hours. When we get into the zinc-enriched paints that we have the ability to spray here, you're looking at about 450 hours. So about 9 times the corrosion protection on that spray. So it really comes through what are some of the sprays that we can put on to protect the spray. And that's really where we're focused on, is making sure that whatever we're putting out into the marketplace on a fire truck, we utilize zinc-enriched paint, because it's proven to provide a much more robust protection on those springs, which is where we normally see the failures.
Sure.
So we talked a little bit about maintenance. You talked about, the weight of a spring pack and removing that U-bolt and getting in there to work on it. How about from a preventative maintenance standpoint? If I've got a spring versus an air ride, are there different preventative maintenance procedures that I have to follow?
Yeah, I mean, every suspension manufacturer is going to have their own PM schedule, right? In terms of how often we want to be touching, what joints do we want to touch. Obviously on a multi-leaf spring, it's a pretty simplistic system, which is one of the pros of it. The problem is it doesn't perform nearly as well. So you kind of have to pick your poison, right? If you're willing to do the maintenance or preventative maintenance and the upkeep on your trucks, I can do just as well with an air ride, keeping that truck in the field and in service, as I can with a truck that doesn't require nearly as much maintenance. It's just, you need to ask yourself and be honest, what is my fleet really capable of? Do I need to sacrifice ride quality because I know I can't touch these trucks once every couple of years? Or do I have a robust enough maintenance program that I can touch a truck every year and do a full PM and keep that truck on the road? So it's really a function of really looking yourself in the mirror and saying, what is my fleet specifically capable of?
So we don't get into price from the standpoint of saying, hey, how much does a suspension cost? Because number one, it'd be impossible for you to tell us, because there's a cost to the manufacturer, then there's the installation and things like that. But just from an overall magnitude, are we talking a big difference in how much an air ride costs versus a spring pack?
No, it's interesting when you look at the amount of information that firefighters and fleets will spend time on. The majority of time is spent on things that you can look, touch, and feel, right? The electronics, the pumps, the things like that. It's always amazing to me that because you don't see the suspension, you don't spend a lot of time trying to research it, because it's there. It either works or it doesn't. But it's one of 4 or 5 major components that's utilized every time the truck is going out, whether it be for a call or you're just going to get your food for your shift, right?
Right.
When we look at the cost delta between the two, what is an average fire truck now? About $1 million?
Yeah.
You're talking less than 0.5% of the fire truck. So, but it's something that's used every time, So that's why I try to do my best to give everyone the options as to what's out there and give you the best riding and handling fire truck that we can provide at Hendrickson.
Sure. And before we close out today we like to close out with the top 3, but before that, is there anything that you think gets overlooked or that should be said more when it comes to that department and they're getting ready to spec that rig and they're looking at the suspension options? Is there maybe a big message?
Yeah, ask the question, right? Have an honest discussion of what do you want the truck to do? What's the most important things to you? Is it maneuverability? Is it ease of maintenance? Is it that you want the truck to handle like your IFS truck does today? Like, what's important to you? And have that honest discussion. And, reps like myself, we want to have those discussions with you. We want to educate you. I just want you to get the best performing fire truck that you can get, whether it utilizes my products or the competitors. That's all of our goals in the fire service is to provide information.
Sure.
So, I think that the most important things you should be looking at is ride and handling important to you? Have the honest discussions. What are you capable of from a maintenance standpoint? And then how long are you going to keep your fire trucks in service, right? If you're being asked to keep a fire truck in service a really long time, to me, it's beneficial to try to protect that fire truck as much as we can. And then if I can put a lot less road inputs into that truck over the course of to say 10, 15 years, the higher probability that I'm going to be able to keep that truck in service.
Great points today, Bob. And I think there's a lot of stuff that I learned that I didn't even know. So I think you guys are doing a great job of educating the fire market on that. Before we close out with our final things, Jason, I'll open it up to you for a final wrap up here.
So the one thing Bob started off with, something I think that is a core point that everyone should take from this. We already hammered home that it's not just about ride quality for your people, but it's the components. So think about it. Electronics. You've got a lot of expensive electronics on there. Sure, we vibration test stuff. We try to make it all bulletproof, but the more you shake it, the more chance you have of something breaking on it. Your body. We build different aluminum bodies, stainless steel bodies. They're all susceptible to breaking if you really put a pounding on them. Think about all those things that go into it. And one of the tire companies has the saying, everything rides on us. Well, everything's riding on that suspension too. So don't overlook it. Make sure that you put the right amount of attention into it. You find out what's the best out there, and don't hesitate to spend a few more dollars for something that's going to make your truck last longer and be safer.
Yeah. And Jason, one more point there. You brought up tires, right? A lot of times I'll talk to fleets, and whenever we get a ride complaint, a lot of times they don't understand that tire pressures fluctuate based on the load you're carrying, right? Every tire tire manufacturer puts out a weight to pressure load chart. So just because it says 110 PSI on the side firewall maximum inflation doesn't mean we should always be inflating to 110 PSI. Because what tends to happen is when you overinflate tires, it creates a basketball effect, and then that travels into the suspension. And a lot of the ride complaints we correct simply by addressing the tire pressure issue, because they've got overpressure tires based on the load we're asking that tire to carry.
Great point.
Yeah, great stuff there. And thanks again, Bob, for your time today and sharing your knowledge with us. I sure found it insightful. So this concludes another episode of Rig Recon Live. Again, if you haven't, follow us on social media. That's at Rig Recon. You can find this podcast wherever you get your podcasts, including YouTube. And make sure you visit our website, rigrecon.com, for all the latest apparatus information. Until then, spec the best.